initially why this PDA, if you remember, we have already shown by um, regular, we have shown by this pumping lemma that the language where we have n number of a's followed by n number of b's, means a to the power n b to the power n, that language is not regular, but a star b star is regular. So what is the difference a star b star and a n number of a's followed by n number of b's? So here we should have equal number of a and b. In a star b star there is no such restriction. So in regular or language or finite automaton, main problem is when we have taken some number of a, so we say we have taken 50a, and for that there is a self loop in some state, say q0. So we have taken 50 transitions and we have got 50a. But when we are moving to some other state, there is no any mechanism to keep that record that how many a we have taken in previous state. So that is the main problem here in finite automaton. So finite automaton is memoryless, and that is creating the problem. Number of a should be equal to number of b. So number of a what we have taken, any number of transitions, we must take the equal number of transitions when we reach to the state which is taking transition on b. But there is no any scope to keep that information. So because finite automaton is a memoryless device, there is no any memory to keep that information. And when people face this problem, then having this concept in mind, in this push down automaton, mainly the finite automaton, with that a memory that was attached or allocated, and that memory here it was taken as a stack data structure. So a stack was taken so that we can store information that how many a we have taken in that transition, and later on when we start taking transition on b, we can get that information from this stack. So a stack along with finite automaton is push down automaton. You can see here we have this input string and states, that is the transition diagram, and this stack associated with that. So these three component stack is additional to finite automaton here. Now how does this stack operate? How, what is the use of it? It is something new to finite automaton. So stack, initially we put some symbol, special symbol inside this stack to indicate that whenever we reach that symbol, that means stack is empty or this is the last symbol on this stack. So we are putting dollar or this z somewhere at this bottom of the stack, and whenever we push some more symbols into the stack, so we pop push say 10 symbols, then if we pop one after another, and whenever we pop either this zero or dollar, these are two different conventions. Some people are keeping dollar, some are keeping z. So either one will keep. So say we are keeping say dollar. So I have say inserted some elements pushed into the stack, and then I will pop one by one. So I am not keeping the record how many elements I have already pushed. I am popping one by one, but whenever I pop dollar, I understand that stack is empty. So to get that indication, we are storing some special symbol which is not coming as operational symbol in that process. And this stack, when we are associating with this finite automaton, so this is stack in insert operation, we know that name is push, and that's why this name of the automaton is push down automaton. How does this operate? Earlier we have finite automaton, they are one state to another. We have only one symbol, that is input. But now, since we have stack, so something to be pushed into the stack or popped from stack, accordingly we have some additions here. What are these? So when we start, not only input symbol, we must get something which is to be popped from the stack. So when we start, one is input as it was in finite automaton, and another one, this is for the stack top sim. So these two should be there, and based on that, we take a transition from one state to another state, Q1 to Q2, and we push a symbol into the stack. So see, from one state to another in this transition, three things are involved. One is input symbol, another is stack top symbol, and once we move from one state to another, something we push into the stack again. So this is the states and transitions in the push down automaton. So here we have certain transitions like this. Q1 to Q2, A comma B, then we are pushing C into the stack. So what is the configuration? Just see, input is A, stack top is B. So something is there in this stack, and this dollar we have introduced as specially designated symbol to understand end of stack. These are already pushed into the stack, E, H, B. So to get this transition A comma B to C, we require A as input and B as stack top. So once we get it, we are moving from Q1 to Q2, and what is there? This B has been popped out. So B will be out of this stack, no longer inside stack. And instead of B, what are we doing? We are pushing this C into the stack. So earlier it was $EHB. Now it will be $EH and C. And PDA is moving from state Q1 to Q2. And this input reading head, this will also move forward one position. Earlier its current symbol was A. Now it will next to A, whatever we are getting, that will be scanned. Same as finite atom. Another possibility is, without popping any symbol, we can push. There are several type of handling. So this is one. See, this is very interesting. Without popping out any element, we can push C. So this is stacked up B and input is A. So A and null, that means we are not popping out anything, but we are pushing this C. So $EHB, and there is a C on top of B. Another one is, we may pop out B, but we may not push anything. So here a $EHB, B is popped out, but we are not pushing anything. So $EH. popped out B and did not push anything, so stack will have $EH. So see here combination. One is popping out something, pushing something, then popping out nothing, pushing something, then popping out something and pushing nothing. So this way we can have transitions. And finally popping out nothing and pushing also nothing, just scanning this input and doing nothing to this stack. So one symbol is scanned but stack remains unchanged. So this is about one symbol popped out, one symbol pushed, and then with that symbol we can have null. So combination with null, we can have symbol pushed, null popped out, null pushed, symbol popped out, null pushed, null popped out. So here you can see symbol and null if we consider. So there are four different combinations. And finally, when we get this dollar, when we pop this dollar, then stack becomes empty, and this is final stage where we compute something. We understand that stack is empty. So there may be possibility we may stop with success that problem whatever we wanted that is done, or there may be some error. So that we'll discuss with specific problems. So stack empty, that is halt, and the automaton halts in state Q1 and rejects the input string. So this is a transition where it is taking out but it is not reaching some state. So this is about, so when stack is empty there is no any transition allowed with empty stack. Good transition is this, dollar is there and we are popping it and pushing something. Next comes this non-determinism issue, similar to non-deterministic finite automaton and deterministic finite automaton. Here also we have non-deterministic PDA and deterministic PDA. Non-deterministic PDA means from one state on A comma B and push this C into stack, so that A comma B arrow C, this is the same for the same thing. We are having two different transitions. One is going to Q2, another is going to Q3. So this is non-determinism. Or without taking any input, input is null, there is a transition. So this is non-determinism. This one here you can given some example of non-determinism. You can see this on null it is going to Q1, on null it is going to Q3. Now some execution we can see here. Uh, this A 3A and 3B and stack is initially having this dollar. So this is initial configuration. Any PDA initially on stack will have this dollar and input is there, and this is the transition diagram of PDA. So initially first we'll show how does it work, and then we'll think about how to design a PDA for a given language. So current state means initial one is Q0, and from there we move to Q1. So it is null and we are pushing nothing and also popping nothing. So we are moving to Q1. Now either we can have input as A or input as B. So depending on input, there is a transition. Now input is here A, so what is to be done? Q1 and A, null is to be popped and A is to be pushed. So you can see here dollar is not popped out, but this input A is pushed into the stack. So what will be the situation here? See, A is pushed into the stack and we have scanned this A. Next, when next input symbol is also A, so this A, what is the transition? Transition is A and you pop nothing but you push this input A. So this transition again Q1 to Q1 and we are pushing this to A. Then again we are getting this third A that is also pushed into the stack without popping any symbol. Then we are getting this B as input. So once we get this B, what is to be done? See this B when we get pop A and push nothing. Push lambda means nothing. So pop A and push nothing. So when we get B, so this A is popped out and we are pushing nothing. Similarly, when we get next P, then pop this A and push nothing. This is Q2 to Q2. Then again when we are getting this B, this Q2 to Q2, this B is input, A is pushed, popped out A and push nothing. So when we have scanned third B, we are at this situation because input is already scanned. We have scanned entire input, so input is null. And what is there on stack top? It is uh, dollar, and we are pushing again dollar. So popping out dollar and pushing dollar again to have this stack restored. And when we are moving to this Q3, so input we have done completed, stack is with null and we are at final state. So this string is accepted by the PDA. So this is about how do we move or realize for a given PDA. There is input and stack, how this operation continues from initial state to the final state. What is this acceptance criteria? A string is accepted if there is a computation such that all the input is consumed and the last state is a final state. So this is about almost the same condition is for finite automata. And one more thing, at the end of the computation, we do not care about the stack contents. So if input is consumed and we are at final state, we accept whatever content of stack, that doesn't matter. So carefully it is to be designed that something is left out on stack and we reach final state, that should not be the situation.
স্যার স্যার কিউ জিরোর ফাংশনটা কি স্যার? আমরা যদি কিউ ওয়ান থেকে স্টার্ট করি তাহলে একটা প্রবলেম কি হবে?
এখানটায় তো
হ্যাঁ স্যার।
that I'll explain. See here, what language it is accepting, on that it will depend. It is designed for some other purpose. Now we'll explain it. Uh, the input string here 3A then 3B is accepted by this non-deterministic PDA. We have already seen that this is because of lambda it is taking. So what type of language it is accepting? This is accepting basically n number of A's followed by n number of B here. So first it is going from Q0 to Q1, then it is taking A and all those A are pushed into the stack. And whenever we have completed scanning all this A, when we get first B, we move to Q2. And for each of this B, we are popping one A out of this stack. So finally, when we find that input is already consumed and nothing is there on stack, means stack is having dollar, that means number of A we have pushed into the stack, those are popped out one by one because of all this B. So number of B equal to number of A. So that is the thing. Now why we are having this Q0, we can start with Q1 as initial state. Good. But the problem is n is equal to 0. That means n is equal to 0 if we take here. That means this lambda means null is accepted. N0 means 0 number of A followed by 0 number of B's. That means it is null. So null is to be accepted. So null acceptance means we should take initial state as final state. So here we are taking Q0 as initial and final, and from there we are moving to Q1. But we can make Q1 as final state to accept null. So if we make Q1 as final state, what will happen? Just see, any number of A will be accepted. Say Q1 is final state. So what happens when we are taking first A? So on you see if we have input only one A, nothing else, only one A. So that will be accepted here. And that it is final state. So we just with one A transition coming to Q1 back and Q1 is final state, it is accepted. So only A is not a valid string, because if there is a, there has to be one B after this. We know this is the language we are trying to accept. So we cannot make this Q1 as final state as well as initial state. So initial state should be something else which is going to accept null as final state, and from there we are with lambda transition we are coming to Q1. Another non-deterministic PDA example is this W W reverse. W is string of A and B. Q0, if there is nothing is as input, lambda going to Q1, lambda dollar dollar going to Q2. Dollar is initial symbol on stack. So null is accepted here, because null and reverse of null is null, and this null and null concatenation is again null, so it is accepted. So if null is input, so it is accepted. Now if we have something else, then how to check? Say ABBA. So AB is W and BA is W reverse. So what happens when we get this A? So whenever we get A on Q0, what we do? We are taking this A and popping nothing, pushing A into the stack. So stack contains A dollar. Then next symbol is B. We are pushing this B into the stack, and then we are getting second here this B. So this is very important issue here. Guess the middle of the string, and that's why it is non-deterministic. So see, if we understand this is middle of the string, if we do not, that we'll have discuss later. But here, say we know this is the middle. So whenever we scan this B, we move from Q0 to Q1 with this all this null, means nothing consumed, nothing popped, nothing pushed. We are moving to Q1. Now when we get this first B, B means pop out B and push nothing. So B is popped out from the stack. Then we get this A. A is popped out from the stack, getting A from input and A popped out, and we get this Q1. And then input is already over, null, and dollar is on stack, and pushing this dollar and going to Q2 as final state. Then comes rejection example. Rejection example, first part is same. This A and B, this will go to stack. And after that, middle, we are moving to Q1. Now first we get B. B is popped out. But now we get input as B and stack top is A. So B comma A, there is no any transition. B comma A, there is no any transition because this is mismatch. And from Q1, we cannot proceed further. But that means it is not accepted. Another computation for this same string, A we are pushing into stack, B also pushing to stack. Then we may think that we have rejected because the middle we could not guess properly. So we are pushing this third B also into the stack, fourth B also into the stack, and we cannot reach final state. Input string we have already consumed. So this is also invalid string. There is no computation that accepts string A, B, B, B. So this is not a member of this uh, language. Now guessing middle point, if we cannot guess it properly, we can try once, twice, thrice with different middle points. At some point, we will find that it has been accepted. And it is rejected that all the input is consumed, the last state is a final state. So if there is no such computation, we say that it is rejected. A string is rejected. What are the conditions? The input cannot be consumed. Some input may be like that. On some symbol, there is no any more transition, and we stuck at some state. So we cannot move further, and we cannot scan remaining input string. Another one, the input is consumed at the last stage is not a final state. So once we have finished scanning of entire string, the current state where we are, that is not a final state. So this cannot be accepted. The stack head moves below the bottom of the stack so that stack becomes empty and we cannot have any more transition. This is another non-deterministic PTA example. N number of A's followed by M number of B where N is greater than or equal to M minus 1. This is the PDA. Only one state Q0, and you can see here A and this lambda producing this A means popping out lambda and pushing A, B and popping A and pushing nothing. So this is the PD. So AAB, is it a valid string? N should be greater than or equal to M minus 1. So here N is 2 and M is 1. So 2 is greater than 1 minus 1, 0. So this is valid. So we are taking this input and this Q0 from there one, when we get A, what we are doing, we are pushing this A into the stack. A is pushed into the stack. Next A, when we are getting, that is pushed into the stack, we are not popping anything because here we have lambda. Then when we get B, what is the thing here? B A lambda means When we get input B, pop out A and push nothing. So for this B, we are popping one A out and pushing nothing. And after that, here we have this lambda. So B, here we can have pop out this thing. So we are at final state Q0 and we have consumed this entire input. So this can be accepted. After that rejection example, you can see A and 3B. So this is violation because N is here 1 and M is here 3. So N should be greater than equal to M minus 1. So 1 and here M minus 1 is 2. So 1 cannot be greater than equal to 2. That's why this is invalid string. This was the relation. N greater than equal to M minus 1. So N is 1 and M is 3. So this is valid. And we check whether this one what we have designed it is correctly recognizing it or not. When we get this A is pushed into the stack. Here nothing is popped out, only pushing A. After that, when we get this B, A is popped out and pushing nothing. So what is there? Stack top is dollar and we have B. So next, when we get this B, B and stack top is dollar and we are pushing nothing. So a dollar is popped out and we are pushing nothing and halt and reject because stack is empty and here we don't have any move for which we can proceed further. So this halting here, the scanning of input string is not yet over and that's why we call it as a rejection. So this is the general format. Pushing string input symbol is here, pop symbol is this one and pushing string is W. So some instruction you will find that this pushing a string that is also allowed. It is not like that the single one we pop out and we can push single only. But popping is only one, but pushing can be done more than one symbol. So popped out only one symbol, but pushing can be done for push down is for multiple symbol that is a string. But only thing is that order is to be maintained. That is important thing. Here CDF, you check CDF is going inside stack maintaining this order. C is on top, then D, then F. So this convention is to be maintained. If you are doing like F on top, then D, then C, it is not correct sequence. So input is A and stack top is B. If it is the situation, then we are popping out B and pushing C, D, F in this order. Another non-deterministic PDA where we have W, that number of A is equal to number of B. There see we have total 6 transition rules here. Q1 we have 6 transitions. First we have A and dollar, that is stacked up one. So for A we are pushing 1 0 into the stack. Next one A and 0. So we are popping out this 0 and pushing 2 zeros. One is for input A and another is restoration of the 0 what we have just now popped out. So we are pushing these 2 zeros into the stack. Then comes A1. So when we get A on input string and 1 on stack top, we are just popping out this one and we are pushing nothing. What is this one? One is when we get a B, we are pushing one into the stack. Just see here, when we get a B, we are pushing it this one into the stack. When we get a B, for this B, we are pushing one, and for this one, what we are now popping out from the stack, that is restored. So we are pushing another one. So this is one is for input, another is for the one we are pushing into the stack. And when we get a B as input and 0 on the stack top, we are popping out that 0 and pushing nothing. So what is these two rules? These are very important rules. What is counting here? First, these four, these are basically, if we get a as input, we are pushing 0 for that A into the stack. If we are getting a B, we are pushing 1 into the stack. But whenever we are getting A as input and 1 on stack top, that means what? Current input is A and stack top 1 means earlier sometime we got some B, and for that we pushed a 1 into the stack. So stack is containing the previous record. So some B was pushed into the stack. So earlier we got some B and now we are getting A. So that is equal. For one A, one B. Similarly, here when we get input as B and some 0 inside stack, that means for this input B, we earlier we have got some A. So number of A is equal to number of B means for one A if I remove one B, and for one B if I remove one A, and ultimately I get all are cancelled out, one is cancelling another, and finally we get null. That means number of A is equal to number of B. That is the logic. We are not counting. Counting is not done because it may be infinite string. So I may have billions of A and billions of B. So we can, if we want to count, we require a huge counter. But instead of doing that, what are we going for? One B is cancelled out for one A and one A is cancelled out for one B. So which one we get first, we push into the stack. And next time when we get its corresponding other one, we are just uh, popping it out and not pushing it back. So this is the logic here. So execution here you can see A, then B, then B, then A, then A, then A, B. Here it is different than the previous one. There was, it was n number of A followed by n number of B. There also it was equal number of A and B. But once a B appears, there should not be any A after that. Format is all A, then all B. That is also a value string in this case. Number of A is equal to number of B, but this is only one instance. But here, number of AB should be equal, but position of A or B could be anywhere. So you can see here, whenever we get A, we are pushing this A into the stack as 0. We are not pushing exactly that A. We can do it, but just to have something different inside stack, it becomes easier to understand. We can put A also in place of this 0, and that can be done. It is possible. So when we get a we are pushing a 0 into the stack. Next time, see, when we get a B, so B is input and 0 is on stack top. So we are popping out this 0 and pushing nothing. So for this B and A, one pair, we have already checked and removed from the system. Next time we get a B, we push 1 into the stack. We are getting second B, we are pushing another one into the stack. Then when we get this A, for A is input and stack top is 1, we are just popping out this 1 and we are not pushing anything into the stack. So A comma 1 and this arrow lambda. So 1 is popped out. Then we are getting another A and stack top is 1. So this is again 1 popped out and we are not pushing anything. Now we have consumed entire input string, and lambda is input, nothing is there, and stack top is dollar. We are pushing, popping it and pushing dollar again to restore stack, and we move to the final state. It is accepted. So this is about acceptance of that. Formalities for NPDS. So transition function, here we have delta current state, comma input, comma stack top. This is equal to the next state where it is moving to Q2, comma W. So W is the string which we are pushing into the stack. It may be a single symbol, it may be a lambda, means null, it may be a string. And this is the situation of non-determinism. For the same input and stack top, it is pushing the same string and moving to two different states. Now this formal definition of NPDA states this capital Q is set of states same as finite automaton, capital sigma, that is input alphabet, same as finite automaton, and this delta is transition function. This function also is same as the, here we know it is infinite automaton was there, but here we have extension because of stack. Q0 is initial state, and F is final state, set of final states, which is a subset of Q. And only two things are extra. One is this gamma and this Z. Gamma is stack alphabet. It contains, generally it contains input alphabet also and some additional symbols, and maybe sometimes some other symbols. It depends on the choice made during design. And this Z or dollar, that is the stack start symbol or the specially designated symbol which is there on the stack at the beginning. So we are having here 7 tuples. 2 tuples here extra. One is stack alphabet, another is stack start symbol. Other things are almost same as finite automaton, only this delta there is a change in definition. Here you can see this instantaneous description of PDA, current state, remaining input, current stack contents. So it was not there in a finite automaton, this is, but here we are adding it. So instantaneous description, Q1 is in the present state, remaining input 3B, you can see here, this is our input. So we have already scanned 3A and remaining 3B. So Q1 and remaining 3B. And what about stack? Stack contains 3A dollar. So this is instantaneous description of present this PDA. So with this description, we understand what is there. But transitions to be known for the next instantaneous description. So next description is Q2 comma 2B and 2A dollar, because we have popped out one, because you see this is the next transition here. We are this lambda and A that we are pushing into the stack that we have already done. Now our target is we are getting this B as input. So once we get B, we are popping out one A from the stack. So the current symbol that we need to explore is 2B, and this A went out from the stack, so we have 2A inside stack. So 2B, 2A dollar. This is our next instantaneous description. So this way we have time 4 is this, time 5 is that, 1B, for 1B we have popped out 1A. So this way we can proceed from initial 1, 3A, 3B, from there 3A, 3B, and 1A going inside stack, then another A going inside stack, another A going inside stack. Then for 1B, we are popping out 1A, for another B, popping out another A, for this third B, popping out third A. So we'll have input as null and stack top as dollar, and then we move to the final state Q3. We have consumed entire input and stack top is dollar. So this way also we can write sequence of instantaneous descriptions from the initial position configuration to the final one. Initial to final, we write by this star. We are not writing all this intermediate instantaneous description. So this formal definition of non-deterministic PDA is LM, W is the string, and this Q0 W is. So this is what initial state, entire input string, and initial stack top symbol. That will lead us to the final state, and input we have already consumed as lambda, and this is S prime, which is stack top symbol. So we once we get this final state and input is lambda, then we are not bothered about the content of stack. So that is the final state we have reached. So once we have some instantaneous description for which from this initial configuration, that is input initial state, that input string w comma stack top symbol, from there using some transitions given by this transition diagram or transition function, we can reach to that instantaneous description where we have final state Q3, input is lambda and dollar stacked up one. Then we can say this W given for checking triple A triple B, that is a member of this language. Similar to this A to the power n, B to the power n, that is also from there we can reach to Q3 comma lambda dollar. This is the string. So this is about acceptance. So this is for some about this PDA description of PDA. Now you have to get some concept about how to design PDA. So designing PDA is only thing you need. Here we have discussed some like n number of A's followed by n number of B's, or number of A should be equal to number of B, or like here the previous one. So we have WW reverse. So WW reverse is again it is even palindrome, also the same thing, the palindrome with even length. But if you are given to design any uh, PDA for any context free language, then you need to understand first what should be the logic. So if we have like a to the power m, b to the power n, m greater than n or m less than n, so there you have to do some kind of extra exercise what is given for m equal to n. So this we need to think that if there is a relation, and how can we check whether it is same or not. So we need to utilize stack. So we are initially storing some information into stack, and when we are getting the remaining part of it, we are popping one by one. And finally we say that input is we have consumed input and nothing is remaining inside stack, and we can accept it. I would say that you the last class we have discussed some languages for context free languages, you can design push down automata for those languages, because any grammar, any context free language may be given to design a grammar or PDA. There are some other logic like any context free grammar, from that we can design a PDA, or from a PDA we can design a context free grammar. There are procedures.
স্যার টার্ন স্টাইল নোটেশনটা স্যার কি জিনিসটা?
কি বুঝলাম না?
টার্ন স্টাইল নোটেশন পিডিএ তে দেখছি অ্যাকসেপ্টেন্স অফ ফাইনাল স্টেট।
কি নোটেশন আমি এখনো বুঝে উঠতে পারিনি।
স্যার টার্ন স্টাইল TURNSTYLE।
ট্রান্সটেড?
না স্যার টার্ন স্টাইল, টার্ন স্টাইল উলম্যানে স্যার দেখছি ওইভাবে করা আছে, মানে সব এক্সপ্রেশন গুলোতে ইউজ করেছে মোটামুটি।
কি আবার বলো স্পেলিংটা?
TURNSTYLE।
না, সে নোটেশনটা কি এরকম কিছু নয়?
স্যার নোটেশনটা উল্টো টি করে লেখা আছে, মানে রিভার্স টি, মানে টিটাকে 90 ডিগ্রি রোটেট করে দিলে যেরকম হয়, অ্যান্টি ক্লকওয়াইজ রোটেট করে দিলে।
সে নোটেশন চেঞ্জ হতেই পারে।
ওই নোটেশনটা মানে কি ডিনোট করছে ওটা বুঝতে চাইছি আর কি।
ও, এইটা, এই এই টিটাকে 90 ডিগ্রি রোটেট তো, এটা হচ্ছে তোমার
আচ্ছা
এই যে আমরা যেটা ডিসকাস করলাম এইমাত্র, সে হচ্ছে sorry, present। আমরা এইখানটায় যা লেখা আছে, এখানটায় লেখা আছে যে এই যে এই জিনিসটা, এই যে ইনস্ট্যান্টিনিয়াস ডেসক্রিপশন থেকে আরেকটা ডিরাইভ করছি, এখানটায় কি বলবো, এটা যেমন ধরো গামা বা আরটাকে 90 ডিগ্রি রোটেট করলে যা হবে, ওখানে টিটাকে 90 ডিগ্রি রোটেট করলে যা দাঁড়াচ্ছে আর কি। এটা হচ্ছে যে
এইটা
একটা ডেসক্রিপশন থেকে আরেকটা ডেসক্রিপশন যে যাচ্ছি, এটা তো ইকুয়াল হচ্ছে না, মানে this is derived from that, or this description is the next description of that, এইটা বোঝানোর জন্য কিছু একটা সিম্বল ইউজ করেছে। মানে
আচ্ছা
ইকুয়াল টু লেখা তো যায় না, কারণ এটা তো এই স্টেট থেকে এই ডেসক্রিপশন থেকে ওই ডেসক্রিপশনে যখন চলে যাচ্ছে, তখন ইনপুটটাও চেঞ্জ হয়ে যাচ্ছে, স্টেটটাও চেঞ্জ হয়ে
এই
যাচ্ছে।
স্টেটটা চেঞ্জ হয়ে যাচ্ছে, ওটা তো ডিএফএ তে স্যার বা এনডিএফএ তে স্যার অ্যারো দিয়ে ইন্ডিকেট করেছিল স্টেট চেঞ্জটাকে।
না না, ইনস্ট্যান্টিনিয়াস ডেসক্রিপশন তো এরো দিয়ে লিখিনি, এরকম টাইপই লেখা ছিল।
আচ্ছা
এরও তো তোমার মানে ফাংশনে ছিল যে এই এইটা থেকে ওটা হচ্ছে, কিন্তু এন্টায়ার মেশিনটা যে একটা ডেসক্রিপশন থেকে আরেকটা ডেসক্রিপশনে যাচ্ছে, সেটার
মানে ওই ডিএফএ ডায়াগ্রাম যেগুলো করেছিলাম আর কি, ওখানে তো Q0 Q1 ওগুলো সব অ্যারো দিয়ে দিয়ে আর কি লিঙ্ক করানো ছিল, মানে
মানে
আপনার ওই যখন একটা ডিএফএ যখন ডায়াগ্রাম আঁকছি তখন যে রিপ্রেজেন্টেশনটা করেছিলাম ওখানেও তো স্যার Q0 থেকে Q1 স্টেটে যাচ্ছে, Q1 থেকে Q2 স্টেটে যাচ্ছে, ওখানেও স্টেট চেঞ্জ হচ্ছিল তো স্যার।
কোনটা দাঁড়াও, কোনটা ছিল? ইনস্ট্যান্টিনিয়াস ডেসক্রিপশন কোন স্লাইডটা ছিল তাহলে দেখলে হবে। ফাইনাইট অটোমেটার এই আইডি ছিল না কোথাও কোনো স্লাইডে?
অ্যাকচুয়ালি স্যার আমি বইয়ের থেকে আপনাকে বললাম আর রুলম্যানের বইটা থেকে।
হ্যাঁ, কোন কোন স্লাইডটাতে ছিল আমি মনে করতে পারছি না। আমাদের ইনস্ট্যান্টিনিয়াস ডেসক্রিপশন কিছু একটা ছিল তো কোথাও ফাইনাইট অটোমেটাতে।
মাঝে মাঝে রিভার্স টি লিখছে, আবার মাঝে মাঝে রিভার্স টি করে উপরে আবার মানে স্টার্ট দিয়ে দিচ্ছে।
না, স্টার তো হচ্ছে মাল্টিপল যখন হচ্ছে, ইন্টারমিডিয়েট গুলো যখন
হ্যাঁ
লিখছে
মানে
না
অল
সেটাই
পসিবল যেটা হচ্ছে। হ্যাঁ হ্যাঁ হ্যাঁ।
ইন্টারমিডিয়েট গুলো যখন লিখছে না সেটাই স্টার লিখছে।
হ্যাঁ
আইডিটা কোথায়, কোন স্লাইডে আমি এখন খুঁজে পাচ্ছি না, সেটা বললে মানে এটা কোনো ইস্যু না, এটা জাস্ট
আমি
একটা সিম্বল
স্যার
ইউজ করা হচ্ছে একটা ডেসক্রিপশন দিয়ে
হ্যাঁ
আরেকটা
হ্যাঁ
ডেসক্রিপশন বোঝানোর জন্য।
হ্যাঁ স্যার ওটা আইডি পার্টের মধ্যেই আছে, পিডিএফ এর আইডি পার্টের মধ্যেই আছে, ইনস্ট্যান্টেনিয়াস ডেসক্রিপশনের মধ্যেই এটা আছে অফ
হুম
দ্য পুশ
হুম
ডাউন অটোমেটিক।
কিন্তু ফাইনাইট অটোমেটাতে আমরা কোথাও এটা ইউজ মানে কোনো আইডি টু
এমনি
আইডি
ফাইনাইট
লিখেছিলাম কিনা
ফাইনাইট
মনে করতে।
অটোমেটাতে স্যার, না ফাইনাইট অটোমেটাতে স্যার ডেল্টা ইউজ করেছিলাম আর কি। মানে ডেল্টার ওপরে আর কি একটা সিম্বল দিয়েছিলাম, ওইটা ইউজ করেছিলাম ফাইনাইটের জন্য।
সেটা
আর
তো ডেল্টা তো
পুশ ডাউন অটোমেটা,
ট্রানজিশন বলি, সে তো ট্রানজিশন
হ্যাঁ
লিখেছিলাম, ইনস্ট্যান্টিনিয়াস ডেসক্রিপশন তো লিখিনি। দেখ ওই এই যে এখানটায় আমি দেখেছিলাম। আহ, এই যে এখানে আমরা মানে এই কোন নেক্সট কোন স্টেটে পৌঁছচ্ছে ইকুয়াল টু স্টেট লিখেছি,
হ্যাঁ
পুরো ডেসক্রিপশনটা লিখিনি। পুরো ডেসক্রিপশনটা মানে হচ্ছে কোন স্টেট কোন ইনপুট মানে রিমেইনিং ইনপুট কি আছে সেটা যদি লিখি তাহলে ওই আর ইকুয়াল টু লিখতে পারবো না তো।
আচ্ছা আচ্ছা আচ্ছা। হ্যাঁ স্যার এই ডিফারেন্সটা জানা ছিল।
হ্যাঁ, যেমন এই যে এখানটায় ধরো Q0 এই এ বিবিবি এ লিখলাম, ইকুয়াল টু যদি আবার এখন স্টেট দিয়ে লিখতে যাই যে উইদিন ব্র্যাকেট স্টেট যে নেক্সট স্টেটে যাচ্ছে কমা রিমেইনিং মানে ইনপুট কি থাকলো, তখন আর এইটা লিখতে পারবো না। তখন অন্য ওই সিম্বলটা ইউজ করতে হবে যে ইট ইজ দিস ডেসক্রিপশন ইজ দ্য নেক্সট ডেসক্রিপশন অফ দ্য দিস প্রিভিয়াস ওয়ান। আমরা এই যে প্রথম ইনিশিয়ালটা থেকে ফাইনাল অবধি যাচ্ছি, ইন্টারমিডিয়েট যে কটা ট্রানজিশন থাকছে সেইভাবে আহ, লেখা আছে।
ঠিক আছে।
আসলে ফাইনাইট অটোমেটাতে তো শুধু ইনপুট আর স্টেটস একটা নেই, তাই ইনস্ট্যান্টিনিয়াস ডেসক্রিপশনটা স্টেটের
ওটা
উপরই ডিপেন্ডেন্ট থেকে যাচ্ছে। এখানে তো আবার এই স্ট্যাকটা রেড হয়েছে বলে এটাকে একটু আরো বড় করে লেখা।
হ্যাঁ স্টেটের উপরে, ইনপুটের উপরে, স্ট্যাকের উপরে সবকিছু মানে
হ্যাঁ
চেঞ্জ অফ স্টেট ডিপেন্ড করছে। ঠিক আছে।
হ্যাঁ, তো এর জন্যে ওইটা মানে ডিরাইভড ফ্রম দিস স্টেট টু দ্যাট স্টেট। এবার নোটেশনের নাম যেমন এর জন্যই উলম্যানের বইটা তে লেখা থাকবে, কারণ উলম্যানের হচ্ছে যে ওরা এই সাবজেক্টে ওদের অনেকটা কন্ট্রিবিউশন আছে এই অফ ক্লড বা জেডি উলম্যান। জেডি উলম্যান এখন ৮০-র উপরে বয়স, তো সে মানে উনি আবার টিউরিং অ্যাওয়ার্ড পেলো, অ্যালান টিউরিং অ্যাওয়ার্ড, এত বছর পর টিউরিং অ্যাওয়ার্ড পাওয়াটা একটা বিরাট ব্যাপার। তো ওই বইটা যে ওনারা লিখেছেন সেটাতে ওনাদের নিজস্ব অনেক কিছু কন্ট্রিবিউশন আছে। এটা একটা ফ্যাক্টর বই লেখার ক্ষেত্রে, অনেকেই বই লেখে
নোটেশন
নোট
গুলো ওরা
বইয়ের
নিজের
মতো।
মতো নিশ্চয়ই।
এর জন্য ওরা যেহেতু নিজেরা এইটা করেছে, এর জন্য অনেকটাই কংক্রিট ওয়েতে লিখেছে, নোটেশন ইত্যাদি দিয়ে।
আচ্ছা আচ্ছা।
সবকিছু ডিসক্রাইব করা তো আমরাও ডিসকাস করতে পারি না। এই যে উলমানের বই দেখেছো, কত বড় বই, এবার সব কটা টপিক এইভাবে ধরে ধরে প্রত্যেকটা জিনিস বোঝাতে গেলে তো
হ্যাঁ, হ্যাঁ।
টাইম লাগবে। ঠিক আছে, ওকে। আর আর কারোর কিছু আছে জিজ্ঞেস করা? তাহলে আমি ক্লোজ করে দিচ্ছি।